How's it going, everyone? Today we're going to be talking about lunar eclipses. There's one coming up, right? So what better time than now to talk about what a lunar eclipse is and what are different effects that happen during the lunar eclipse? Why does it happen the way that it happens? So you've probably heard, okay, lunar eclipse is when the moon enters the Earth's shadow. Well, what exactly is happening there? Okay, if you imagine this is our sun, this is the Earth. Okay, obviously this is not to scale. So the sun shines on the Earth, but the Earth blocks some of that sunlight. So let's take this point on the sun's surface, for example. Okay, so what areas will block out light from that particular part of the sun? Well, this shaded area right here. Okay, it will not be receiving light from that particular part of the sun. But, well, what about this part of the sun? Okay, so what will be blocked by that? Okay, so let's draw those lines, okay, from that point tangent to the Earth's surface. So now we have a different area where the sun's light is blocked, right? So that would be this area right here. So some of what was blocked that was emitting from this point, well, it's not blocked if it's emitting from this point, right? So the question is, are there any areas from which light is blocked regardless of what part of the sun that light comes from, right? And to do that, we have to look at the very, very edge of the sun and get that tangent line that is tangent to both the sun's surface and the Earth's surface, right? And that'll show, and I'm actually going to draw this below again, that'll show an area behind the Earth which blocks light emitting from all parts of the sun. So let me just draw this lower for you. Okay. So there you have your sun, there you have your Earth, and if we draw these tangent lines, okay, then you get this area right here, where light from all portions of the sun is blocked. Now if we draw these tangent lines, then we see, okay, all the place where light from that corner of the sun is blocked, and all the places where light from that top, not corner, but edge of the sun is blocked. And so this dark region here, that's the Earth's shadow. Okay, it looks sort of triangular. It's actually a cone, right? Because the Earth is a three-dimensional object, as is the sun, and so you have shadow here as well, and that's where there is night, right? Because the Earth is blocking light from the sun during night for us. But actually this is more of a three-dimensional cone. Okay, so the Earth's shadow is this cone in three-dimensional space. Okay, now the areas beside the cone right here, this is called the penumbra. Okay, so in these areas here, parts of the light from the sun are blocked, but they're not completely in Earth's shadow. Okay, so if you are positioned in Earth's shadow, let's say you're the moon and you're positioned right here, okay, well, you're completely in Earth's shadow, and technically you wouldn't see the sun from here. Realistically, you will see some sunlight, but we'll get into that later on. If you're positioned here, well, you can see the entire sun, okay? And your view of the sun is not obstructed by the Earth. If you're positioned in the penumbra, well, you can still see the sun, but your view of the sun will be obstructed, at least partially. Not at least, it'll be partially obstructed by the Earth. Okay? But you'll still see parts of the sun. It's directly in this shadow where the whole sun is blocked, and so the entire moon falls within Earth's shadow. Okay? So when this happens, okay, what does it look like? Well, first of all, if we see the moon, let me draw that for you. So you're looking up at the sky and you see the moon, and you see that shadow of Earth starting to creep along the moon. Well, you'll notice that shadow is curved, okay? And that's because, and as it moves, it's curved even more and so on, right? And that's because the Earth itself is round, right? So it's round, it casts a round shadow. That's one way you can see the curvature of the Earth without actually going to space and looking down on the Earth. I've done a separate video about that, and I'll link that in the description of this video, different ways you can see that the Earth is round without actually going into space. The other interesting thing is that when you look at a lunar eclipse, and if you've seen it before, the moon doesn't disappear. Okay, I mean, the reason we see the moon as being white is because it reflects light from the sun. Okay, but when you look at the moon during a lunar eclipse, theoretically it's not getting light from the sun, but you could still see it. It's just instead of being white like usual, it's this kind of reddish, brownish, orangish color. So why is that going on, right? It's not like the Earth's shadow is casting this light, right? So why is it reddish, orange, brownish? Well, here's what's going on. Okay, if you're observing, let's say you're on the moon's surface, and you're observing Earth, right? So there's Earth during a lunar eclipse. What you're actually going to see is you're going to see a little bit of red sunlight along the edges here. Okay, what you're actually seeing is all of the sunrises and all of the sunsets happening on Earth. You're seeing all of that at the same time. And it's going to be this red shine, okay? And this is related to the fact that when we see the sun during sunrise or sunset, it looks more red, okay? So here's what's going on. Let's go back to Earth now, okay? So here we are on Earth. Let me draw that with a black color, okay? Here we are on Earth. The Earth has an atmosphere. Okay. So if we're observing sunrise or sunset, right, the sun is on the edge of the horizon. Okay? So to us, it looks like the sun is somewhere over here. Okay? And you see the sun is passing through a thick part of the Earth's atmosphere, okay? Compared to if the sun is somewhere up there, okay, well, then it's passing through a much thinner part of the Earth's atmosphere, okay? So what's happening here is when light passes through something that disrupts that light, like air particles, right? Rather than moving through the vacuum of space, it's moving through air particles, right? Then that is going to affect which wavelengths of that light are going to get through, right? So sunlight is white, right? And that includes the wavelengths of all the colors of the rainbow: red, orange, yellow, green, blue, purple. But the more that light travels through the atmosphere, the more the short wavelengths like purple, blue, green become absorbed. They don't get through, whereas the longer wavelengths like red and orange, they get through much better. That's why on an intersection, for example, the light that tells you to stop is the red light, okay? Because you can see it from farther away. If it's foggy, it's more difficult for that light to get through, but the red light is going to get through farther than the yellow, which is going to get through farther than the green, right? So when the sun is passing through the thickest part of the atmosphere, the sun's light is passing through it, it looks more red. And then as the part of the atmosphere it passes through gets thinner, then the sun starts to look more orange, and as it gets even more thinner, then the sun starts to look more yellow. Now, as the day progresses, now it's passing through a thicker part of the atmosphere again, so once again it looks more orange, and eventually, as the sun is at the horizon again, it looks more and more red. Okay? So the sunlight is passing through a thick part of the Earth's atmosphere, and that's why it looks more red. And so observing the Earth from the moon during a lunar eclipse, you see that light which is passing through the Earth's atmosphere, so it's more red, So it's more red light hitting the moon, so it's more red light reflecting from the moon, and so you get this reddish light that you see when you look at the moon during a lunar eclipse, this reddish, orange, brownish light. Okay, but hold on a sec. If the whole moon is in Earth's shadow, why would we be seeing any light? Wouldn't it be behind us? If we're seeing light, doesn't it mean we're not really in Earth's shadow? Again, if we're on the moon. Well, here's the other thing the atmosphere does, is it bends the light. Okay, just like your finger looks different if you put it in a glass of water. Okay? Light travels with a different speed in different material, right? So this light may be traveling through a vacuum, the vacuum of space, but once it hits the atmosphere, that light bends and moves in a slightly different direction. So if you're here observing things, you're seeing the sunlight coming from here. And so to you, it looks like the sun is positioned over here. It also looks more red because it's going through a thick part of the atmosphere. But the real sun is right here. And a straight line from the sun to you wouldn't actually reach you. Okay, the sun has not risen yet. But to you, because of how the light is bent by the atmosphere, it looks like the sun has risen, even though it hasn't risen yet. And the same thing happens when the sun is setting. Okay, you see the light coming from here, so to you it looks like the sun is over here, but realistically, the sun is here. But that light is bent by the atmosphere, which makes you think it's coming from a different direction. The actual sunlight directly from the sun, it can't reach you because it's blocked by the earth. The sun has already set, but to you it looks like it's still setting. And of course it looks red because it's passing through a thick portion of the atmosphere, right? This kind of illusion is created. So what happens in our moon, earth, sun system, okay? There's our sunlight. Okay, so there's our shaded region where we have Earth's shadow. Okay, and here's our moon within Earth's shadow. Okay, but Earth has an atmosphere. It's got an atmosphere, so some of that light, as it's passing through the Earth's atmosphere, it's going to bend rather than continuing in a straight line. It's going to bend rather than continuing in a straight line, and it will reach the moon. Okay, and of course after this point right here, that's when it becomes more red because it's passed through such a thick portion of the Earth's atmosphere. And so even though the moon is completely in Earth's shadow, some of the sunlight does pass through because it gets refracted as a result of the Earth's atmosphere, right? So it would be really weird to be standing on Earth looking up at the sky and there's the sun and there's the moon eclipsed by the Earth's shadow, but I mean, you can see one here and one here at the same time. Can't the sunlight just go like that? Why is the moon eclipsed? Okay, and that has to do with that atmospheric refraction. Okay, so if there's the Earth, and it's much easier to see this if you're elevated, like on a mountain, right? And here's your observer, and here's your atmosphere. And of course, this is exaggerated. The atmosphere is not that thick relative to the size of the Earth. There's your moon. There's your sun, of course not to scale, right? So you can look in one direction and see, oh, there's the moon. And you can look in another direction and think, oh, there's the sun. Okay, but what's actually happening is the sun is shining from here and the light is getting refracted, and so it looks like the sun is here. The moon is shining from here, or not shining, it's reflecting whatever amount of reddish sunlight there may be from here, and then that light is getting refracted again once it reaches the Earth. And so it looks like the moon is here, right? And in this situation, of course, the moon is in the Earth's shadow, okay? And that's how you'll see it here, because that's the light that's being reflected, that shadowed up moon. So you end up with this situation. You can see the sun and the moon covered by the Earth's shadow, not getting so much sunlight at the same time, and it looks very strange. And that's an illusion that can happen. Okay. Another interesting thing is, well, why don't we have a lunar eclipse every month, right? Because every month, at some point, the moon is going to be in a position. There's our sun, there's our Earth. The moon is going to be in a position where it's on the opposite side of Earth, right? So why don't we have a lunar eclipse every single month? And the reason is that the plane of the Earth's orbit is not perfectly in line with the plane of the Earth's orbit around the sun. Okay, if we look at this situation from the side, it actually looks more like this. There's our sun. There's the plane of the Earth's orbit, okay, flat-ish, okay, there's the Earth. But the plane of the moon's orbit is on a slight slant, okay? So when the moon is on the opposite end from the Earth is where the sun is, it's not actually falling into Earth's shadow, okay? It's above Earth's shadow, or it might be below Earth's shadow. It doesn't always necessarily be in line like that, not every month, okay? But during a different time of the year, the situation might look like this. There's the sun, there's the Earth's orbit, okay? There's the Earth right here in front of the sun, that's our sun, okay? And there is the moon's orbit, okay? And there's the moon right here. So in this case, you would have a lunar eclipse, right? So it's not enough for the moon to be on the opposite side of Earth as where the sun is. Considering the angle of the orbit, it also has to be crossing the orbit of the Earth around the sun right when the moon is in front of the sun as well. So you need that perfect alignment, and it happens approximately twice a year, okay? And that's why we don't see a lunar eclipse every single month. Now, another question then we can ask is, okay, well, let's say it's a month where these orbits are aligned, right? So there's the sun, and there's the Earth, and there's the moon, okay? And everything's aligned, right? So if we get a lunar eclipse, then at some other point in that month, wouldn't we also get a solar eclipse? So shouldn't solar eclipses be just as common as lunar eclipses? How come solar eclipses are so much more rare? Well, the answer is they're not more rare. Solar eclipses do happen just as often as lunar eclipses. Okay? The difference is how many people can see them. Okay? If we have a lunar eclipse going on, the Earth is much bigger than the moon. Okay? So the entire moon can fit in Earth's shadow. And so everybody who has nighttime at this time is going to see that lunar eclipse. That's half the Earth that's going to see it. Right? But what happens when the moon is between the Earth and the sun? Well, the moon being much smaller than the Earth, you have a situation like this. There's the moon's shadow. The Earth's not going to fit in that shadow. The Earth is much bigger. Okay, so, whoops, that's some... We don't know where that came from. Okay, let's draw the Earth better there. Right, the Earth is much bigger than the moon, so that shadow of the moon is only going to it's only going to land on one part of the Earth. And it'll trace along part of the Earth as as it progresses throughout the day. So only a small part of the Earth is going to see that solar eclipse, whereas half the Earth is going to see a lunar eclipse that month. Okay? So it's not that lunar eclipses happen more often. They happen just as often as solar eclipses. It's just a lot more people can see them. If you were to travel around the Earth chasing eclipses, well, then you would see a lunar eclipse every single month that you see a solar eclipse. And vice versa. They coincide because they do happen during the same month, approximately 2 weeks apart. Okay? So another question people often have is there some effect that the lunar eclipse has on people? Is there some effect that it has on the Earth? Okay, and often people's questions are of a mystical or astrological nature, right? What effect can it have? Well, I'll tell you what effect it can have. First of all, if you have a lunar eclipse, right, it happens during the full moon. And it happens during the full moon because the full moon is when the Earth is on the opposite end of the Earth as the sun is. So all the effects that happen during a full moon, they're also going to happen during a lunar eclipse. Okay, so for example, tides are stronger during the full moon. Okay, because tides are a result of the Earth-Moon system, and when the Earth-Moon-Sun system, and when the Earth and the Moon and the Sun are aligned, tides tend to be stronger. Okay? So what else happens during the full moon? Well, it's brighter outside, right? So whatever effect brightness has on people or on other animals, that's going to happen during the full moon. Now, since the invention of electrical lights, that brightness doesn't have as much of an effect on us, but maybe it used to have much more of an effect. There are animals that we've seen in studies that during the full moon, they do behave differently, and that difference is attributed to the fact that it is more bright outside. And during the lunar eclipse, well, it's actually less bright than it would be if it were not for a lunar eclipse. So if you look at the lunar cycle, right, as time goes on, right, when you have a new moon, it's least bright. And then when you have the full moon, it's most bright. And then it's the new moon and it's least bright again. And so the cycle continues, right? So you have new moon, and then you have full moon, and you have your crescent moons somewhere in between there, right? And here you have no moon at all during new moon, right? And your crescent moons in between. So if it's a lunar eclipse, well, what happens is one night during that full moon phase, that light actually dips, right? And then continues as usual, okay? So it's getting brighter and brighter and brighter at night, ignoring, weather effects or electrical lights. And right before the full moon, the lunar eclipse, it's full moon at night. And then boom, lunar eclipse, brightness dips. And next night, oh, full moon again, right? So this function of how bright it is at night, it changes, right? It changes it because it has this downward spike in the middle during the months of the lunar eclipse. So whatever effect that could have, it has that effect, right? And some animals, because of that dip in brightness, they will behave differently, okay? Now, what about psychological effects on humans, right? Well, simply put, if humans are aware of the lunar eclipse, they want to be outside more because they think it's interesting, and so more humans will go outside, and that's an effect. And you can say, oh, the lunar eclipse has an effect on humans. It makes them go outside more and stay up later. Well, yeah, kind of, but it's because we find it more interesting, right? And that could have been the case before electrical lights, right? When just the moon is full, it's brighter outside. It's interesting. It looks nice. People want to go outside. People are hanging out later, okay? And when you have more people spending more time together later into the night, what's going to happen? Well, you're going to have more fights break out, just because with more people, it's more likely to happen. At some point, you're going to have more accidents happen. You're going to have more sexual activity. And if it's something particularly interesting, like a lunar eclipse, well, even more reason to have more accidents, right? Even more people are going to want to go out and look at that right? Even higher likelihood of fights or people interacting and sexual activity and accidents. Someone's driving in their car, they want to look to the side to look at that lunar eclipse. They're more likely to get in an accident because they're more distracted. More likelihood of drivers being distracted on the roads, more likelihood of accidents. And someone could look at that correlation and think, wow, when there's a lunar eclipse, more fights happen. More babies were conceived. Okay? More accidents occur. So, is the lunar eclipse a more dangerous phase? Well, kind of, if there's more distracted drivers on the road. And if there's higher tides as well, just because it's a full moon, well, that's more dangerous too. So yeah, it is a more dangerous phase. Is the moon emitting some sort of magical energy that is causing people to be more reckless? Well, kind of. It's not emitting it, it's reflecting it. It's reflecting sunlight. And the sunlight happens to be red, which is unusual because usually it reflects white sunlight. And that's more interesting, right? So more people want to go and spend time outside, and they want to go out and stay out later. And with more human behavior in general, you have more reckless human behavior as well. So when an astrology magazine tells somebody, oh, be careful around the lunar eclipse, right? It could be more dangerous, right? You've got to be more cautious. Well, they're not wrong, but they might be right for the wrong reason, right? Because it's often attributed to some mystical energy, and what's actually going on is, well, you have red light reflected instead of white light. And that's that, right? So that's an effect. That's a real effect that the lunar eclipse has, and we've talked about the effect that the full moon has in general as well. So be careful driving. Don't get distracted. Be careful around other distracted drivers. But if you get the chance, do see the lunar eclipse. It's a cool thing to see. So till next time, enjoy.